right, thank you for having me. I am thrilled to be a part of this Science on Screen. I'm thrilled to talk about this movie, or to lead into this movie, Ammonite, by talking about paleontology for all, the history, practice, and legacy of fossil discovery in the golden age of geology. And so I'll open it up by talking about Mary Anning. And so the protagonist of this film that we're about to watch, Ammonite, is Mary Anning. And Mary Anning was a very early fossil collector, early geologist, early anatomist, born in 1799 and lived until 1847. Mary Anning contributed a number of significant finds to the field of paleontology in a very pivotal time in the field of geology's history from the Western European science portion of that history. And so to give a little context for Mary Anning, I thought we'd talk about what the history or what the status of the field was at the time that Mary Anning was working. So these are three images that are important for the history of geology going into the 19th century, so going into the 1800s. So in the 1700s and then in the early 1800s, geology from the Western European perspective was still figuring out what geology is. A lot of what we take for granted now and assume about geology was being established during this time. So for example, up in the corner here, we have James Hutton, who was at the time arguing about how rocks form. And now we think of rocks forming as part of a cycle, the rock cycle you might have been introduced to in elementary school or middle school or potentially even in college. But at this time, we weren't sure how rocks formed, and so James Hutton was figuring out via observations of rocks intruding into other rocks that there was such a thing as magma intruding and cooling and becoming rocks. Prior to that, there was arguments about whether or not rocks were purely just deposited by great flood events. And so Hutton and others argued it wasn't just great floods, it wasn't great floods at all, instead it was lava cooling to form rocks, and those rocks eventually would enter into a rock cycle where they would break down and re-solidify and be deformed. At the same time, you had a person named Cuvier arguing for extinction. So early in Mary Anning's life, the concept of extinction didn't really exist as we know it today. Instead, there was a debate about whether or not species were just transforming into other species, whether or not they actually went extinct. And so Mary Anning was working at a time and finding fossils of things that were not around today, and this helped establish the concept of extinction. At the same time, this was occurring during the Industrial Revolution. And so somebody like William Smith was using fossils and fossil discoveries to help date the ages of rocks, and this is important for the Industrial Revolution for establishing where coal was. And so you'll notice something about all of these geologists or natural philosophers of the time. These were societies of affluent white men in geology in England, which is where a lot of people attribute the birth of geology as we know it as a Western science. And so these men would gather into societies, and in these societies would talk to each other, communicate, establish ideas, discuss ideas. And these societies would meet to the exclusion often of women, although not entirely. Sometimes if you were a wife of a famous geologist, you were allowed to participate in these meetings. And so what was often missed was the visible contribution of women to geology at this time. And so here you have two women whose names have sort of been lost for the most part to history despite their contributions. So you have, in this case, Mary Lyell, who was married to a famous geologist at the time and contributed to their fundamental work in geology by making their own observations independently and then combining them. So they were looking at shells of fossils, and this helped Lyell understand that processes in geology took time and were slow. Similarly, you have another, Ms. Mantell over here, who helped describe one of the first iguanodons, so a type of dinosaur fossil. And so this is the world that Mary Anning was working in, a world of a particular class of white men who would meet in societies and establish science, and Mary Anning, being a working class person, a female person, was excluded from those meetings. I'd like to pause now to change gears a little bit to talk about the process of fossil collecting. What I found most striking and most enjoyable about the movie for me, when I saw it a little ways back, was how they depicted fossil collecting. And what's most enjoyable about it is, as somebody who goes out and collects fossils, it was very realistic. It was very fitting to see Mary Anning crawling around on the dirt, getting her face close to the rocks. And so I'll show a little bit of some pictures of my own field work now to sort of communicate that what you're going to see in the movie and what you'll see Mary Anning doing while she's collecting fossils is similar to what I do when I go out and collect fossils. And so here we have some images. If you're in these, I'm the person way, way on the left, in the left top image, lying down on the dirt, looking like I might be taking a nap, but instead I'm looking for fossils. And so what we do is we'll go out into the field, we'll use maps, and we'll try and identify where fossil localities are based on previous finds. And if there are no finds in an area, then we'll go to the rock types that we think that those fossils might be in. We'll go out to the field, we'll record observations in our field notes, and we'll crawl around looking for fossils, and eventually we'll hopefully find some fossils. And then we spend some time back at camp identifying those fossils. So we'll be in a tent with microscopes looking, in our case, when we're looking at these small fossils. If we're looking for a bigger fossil, which is often what Mary Anning found, we'll find some little exposure highlighted by that red arrow there, which might be a little hard to see. There's a different color of the material that's highlighted by the red arrow pointed to, rather than the surrounding matrix. And that's what this is. You might be able to see this little black dots here. These black dots are indicating where teeth are. There's a slightly different color. There's a jaw here, and then the top of the skull up there. And so this is an example of a large fossil we found. This is a Brontothera, which is a relative of horses and rhinos and tapirs, a parasodactyl. And so if you find a large fossil like this, what you will do is you'll encase it in a jacket in a plaster to transport it. And so there's a scene in the movie, not to be a spoiler about it, where Mary Anning probably could have used this technique to encase a fossil she found. Once we have those fossils encased, we'll transport them to a museum. At the museum, using prep work, we'll try and remove the surrounding matrix and we just have the fossil left behind. We'll give it a specimen number and we'll catalog it away in a museum. So ideally, these specimens will eventually be published, and then through news media will be disseminated to the public to say, look, we found an interesting new fossil. But more often than not, there's so many fossils found in the field that we often have what are called dark fossils, or fossils that are left in museums not described. From there, often we want to display our really excellent finds. And so those finds will be put on displays in museums. The roles of museums in paleontology have changed. Back in the past, they used to be more of a stamp collection where we would say, look at all the cool things we found, here they are. And now museums have taken on much more of an educational role, displaying not only the specimen, but information associated with the specimen. And so here to highlight that are two images of the Smithsonian, one from the early part of the 20th century, showing cases with fossils on displays as part of a stamp collection, showing these are all the fossils they found. And now a more current representation of the Smithsonian exhibit, where we have not just the fossils, but also educational activities and information associated with them. And so that's how the process of paleontology, getting fossils to the public. Mary Anning, back in the early half of the 19th century, so in the early 1800s, was pivotal in finding a lot of important fossils for the area she was working in and the time that she was working in. So Mary Anning is credited with finding some of the first representatives of plesiosaurs, these type of marine reptiles, these long-necked marine reptiles you might have seen, often mistakenly associated with the Loch Ness Monster, and the first pterosaur found outside of Germany, so a flying reptile. So these are not dinosaurs technically, they're relatives of dinosaurs, much like a cat is not technically a dog, but it is a relative of a dog. And so these fossils that Mary Anning was finding, in addition to ammonites, which are relatives of squids and octopus, these coiled shells, are important fossils for what's known as the Mesozoic era, a time in Earth's history of about 252 to about 65 million years ago. And she was working in Lyme Regis. So this is a map of England, and out here on the southern coast of England, shown up there, there's a little portion right where the blue line starts, where orange meets the blue, is Lyme Regis. And we're working in cliffs like these. These cliffs are marine deposited rocks, so that means that these were at one point sediments that were underwater, and then eventually were exposed as water receded. And so Mary Anning's work, finding fossils like plesiosaur and ichthyosaur and a lot of these marine and flying reptiles, helped us better understand what the area looked like in the ocean during the Mesozoic, during this Mesozoic era. And so this piece of art right here, the Duria Antiquior, is an example of one of the first paleo art. So this was made in 1830 by a friend of Mary Anning's, and this was a piece of art that was sold to help provide financial support to Mary Anning, because Mary Anning, though she was able to sell some of her fossils and in some ways was forced to sell her fossils to be able to support herself as a working class person, needed additional funds, and so this friend of Mary Anning's created this art and sold it. And so this art depicts what their imagination of a Mesozoic marine ecosystem might look like. And so we can see in this artist's depiction different animals interacting, some biting each other, and we can see some of the finds of Mary Anning, these relatives of squids and octopus, these marine reptiles shown here, and flying reptiles as well. And so Mary Anning, one piece of her legacy is our understanding of the marine ecosystems in the Mesozoic. So sort of in contemporaneous with dinosaurs, but in the marine system. Another piece of her legacy is the geologist that she trained. So Mary Anning, again, was often not invited to participate in discussions in the Geological Society in London, but everybody that was a geologist of the time knew if you wanted to learn about geology of England, you had to go talk to Mary Anning. You had to go hunt fossils with Mary Anning to be able to learn the skills that she had developed. And so this is a very incomplete list of some of the geologists who worked with her at the time and some of their accomplishments. And I highlight these three of the much longer list of geologists because some scenes within the movie, which again, avoiding spoilers, but there is a scene in which Mary Anning describes a coprolite to a scientist on the beach, which is a piece of fossilized feces. And so that is actually based on, I imagine the directors based that off of Mary Anning sending a letter to William Buckland describing what a coprolite is, what was known as a bezoar stone at the time. And so that piece of evidence was nice to see in the movie, that they included a little bit of history there, that Mary Anning is credited with describing, at least to a colleague, what a fossilized feces looked like. And then another character in the movie, Murchison, Robert Murchison, is somebody you'll bump into as we're watching the movie, and that's somebody who established some geologic periods. So sometimes they describe the rock that defined that time. And so that's a character you'll see in the movie, and he is somebody who would visit Mary Anning and learn from her. And then I included Adam Sedgwick over here, only because he taught Darwin geology. So Darwin is a famous enough person, I think, that the teacher of Darwin, the person who taught Darwin geology, went to learn from Mary Anning about geology. Another piece of Mary Anning's legacy is shown in sort of the field where we honor her with species names. And so, for example, there's a 2015 study in which a new species of ichthyosaur, this marine reptile, was described, and this species was named Ichthyosaurus anningae. And this is in honor of Mary Anning. And her legacy remains as sort of a piece of our culture in her contributions. And this is shown through women scientists who see themselves or honor Mary Anning and see her representation of themselves as a representation of her, seen in popular culture through movies like Ammonite, and in comics like this one here from Kate Beaton's Hark, a Vagrant comic strip, where they say Mary Anning is excluded from the Geological Society of London. And the last piece of her legacy is maybe not directly tied to her, but sort of seeing her today. She was somebody who was excluded from geological societies. She was an amateur fossil hunter, which is, for paleontology, still a great thing. We still value amateur fossil hunters. We still think people finding fossils is fantastic and contributing to the understanding of the field and of the science. And so I saw this earlier this year. It was popping around a bunch of news sites of a 13-year-old girl who found a megalodon tooth, so a giant tooth, or a large tooth of a shark. And seeing a 13-year-old girl who was fossil hunting with her dad was very reminiscent of Mary Anning, who first initially started fossil hunting with her dad, and her dad passed away when she was a young girl. And that led to her continuing to fossil hunt and continuing to make these amazing finds. and supporting her family through selling these finds. And this continued throughout her life. And so while we hope that it's a much different story for any kids that are interested in paleontology today, it is interesting to see that there are young amateur fossil hunters out there making amazing finds, just like Mary Anning did hundreds of years ago. So with that, I'm happy to take any questions if there are any.
How big was that megalodon?
They, well, I'll just keep holding it.
David, could you repeat the question so people in the back can hear them?
Absolutely. So the question was, how big was that megalodon? And so this megalodon, the rule of thumb is generally for every inch of tooth, you have about 10 feet of a megalodon. And so this is about a 5-inch tooth, so it'd be about a 50-foot shark. So a really large shark. This person was able to find, so a really amazing find. Yeah.
Do you know at what point Mary Anning started kind of gaining recognition for her contributions?
Yeah, so the question is, at what point did Mary Anning start gaining recognition for her contributions? And so it's an interesting question because within her lifetime, people were aware of her contributions. People knew that she was somebody who knew their science, knew their stuff, knew their fossils, and this is what led a lot of English geologists to travel to see her. At what point did she start becoming, well, as part of that, what would happen in her selling her fossils is other people would describe the fossils that she sold to them, and they would be credited with having found that. So for example, this plesiosaur, this long neck marine reptile, there is somebody else's name that is associated with that fossil and will forever be associated with that fossil. Whenever we refer back to the first plesiosaur, it'll be this person's name, which I believe is Kobe Bear. But there is, so when did people start thinking of her as being the person who found the plesiosaur as opposed to Kobe Bear or anybody else? That's a great question. I'm not entirely sure when that transition happened, when we started recognizing more of her contributions, but certainly within her lifetime, people knew that she was a well-regarded geoscientist, just not allowed to participate in meetings. Yeah.
A lot of your work you said you did in Wyoming. Is there like a hot spot for fossils to show up, or is that just relative throughout the country and lands?
Yeah. So the question is, a lot of my own research, and so these images are taken from where I do my field work, and this is in Wyoming, in sort of central, north central, west central Wyoming, in the town, near a town called Worland. And whether or not there is a hot spot for where fossils occur. And so it really depends on the distribution of the rocks. And so there are, within the sort of western, I was gonna say western because I spent so long in the Midwest, within the eastern portion, near the Rockies, there are a lot of great fossil finds out there, in part because the land is exposed, in part because we have access to it. A lot of that is BLM land, so they can be collected on publicly. And that's led to a lot of collections of rock there. Additionally, the rocks are old enough that they have them, they're the right environment. They were deposited in this case, lacustrine environment, river environment, so lakes and rivers, so that they could be quickly buried by sediment after they pass, which allows for fossilization. Whereas somewhere in the western portion of the United States, where we are in California, there might be a little less, except for special circumstances where there would be situations right for fossilization. And so it depends on our access to fossils, but it also depends upon what the geologic environment was. Yeah.
Is that Portland around Yellowstone National Park?
Yeah, so the question was, is Worland, Wyoming near Yellowstone National Park, which is famous for its geologic features like Old Faithful, and it's so Cody is about an hour away. It takes us about an hour to get to Cody. So sometimes we go up by Powell, which is right by Cody, to go digging in that area. And Cody is right at the south, or at the eastern extent of Yellowstone. And so about an hour and maybe some change to get up to Yellowstone. Yeah. Is the site geologically related to Yellowstone? In the sense that it is all geologic related, yes, it's all part of an interconnected system, but it's not the right age rocks, and so there isn't necessarily that shared history, geologic history of the fossils we're looking at in Yellowstone National Park. All right. Done. All right. Well, thank you so much. This has been a true pleasure, and I hope you enjoyed the movie as much as I have.